Could an object speeding through our solar system from the void between the stars actually be an alien spacecraft? On July 1, 2025, a mysterious visitor designated 3I Atlas was discovered, sparking a fierce debate. Was it a natural comet or, the first definitive proof of extraterrestrial technology? One prominent Harvard scientist fanned the flames of speculation while NASA pushed back with hard data. What followed was a clash between radical ideas and rigorous evidence. Let's explore this together. The Atlas discovery in Chile. So, how do we even spot these interstellar travelers in the first place? It starts with a constant vigilant watch of the night sky. The story of 3I Atlas began on July 1, 2025 at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1, a definitive sign it wasn't gravitationally bound to our Sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3Y Atlas with the 3-2 marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second. A truly exceptional catch and a prime target for immediate scientific study. AVU controversial hypothesis. But what if a new discovery doesn't fit neatly into our existing boxes? This is where science can get heated. Enter Avi Loeb, a Harvard astrophysicist and the head of the Galileo Project, an initiative dedicated to searching for evidence of extraterrestrial technology. Having previously sparked debate by suggesting the first interstellar object, MUA, could be artificial due to its observed non-gravitational acceleration, Loeb turned his attention to 3I Atlas. He pointed to its early lack of a visible tail and what he described as a trajectory that might eventually show subtle deviations not caused by gravity. In a paper released on the RxV preprint server, a common practice for rapidly disseminating new ideas, he proposed his radical hypothesis. If the object continued to show no outgassing, it might be a technological artifact. He even raised the hypothetical possibility of malign intent, suggesting it could use the Sun for a gravitational slingshot to alter its course towards an undisclosed target. Loeb was careful to frame this as an intellectual exercise, admitting a natural comet was the simpler explanation. Still, the mere mention of alien technology from a scientist of his stature was enough to ignite a global media firestorm and put serious pressure on the astronomical community to respond. Media sensation versus scientific method. Here's the thing about alien theories. They travel faster than light speed in the media. Avi's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched on to the most dramatic elements of his proposal. The possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle, but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic and proven idea, while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation published on a preprint server before peer review, getting a massive head start on the deliberate evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. Music. NASA's comprehensive investigation. When a claim is that big, you need the world's premier space agency to weigh in. So, how did NASA approach the mystery of 3I Atlas? They didn't rely on a single instrument. They launched a coordinated, multifaceted observation campaign, allocating dozens of hours of precious observation time on their flagship observatories. This involved the Hubble Space Telescope using its Wide-Field Camera 3 to capture incredibly detailed visible light images and the James Webb Space Telescope using its NARSPEC instrument to analyze the object's infrared light for chemical signatures. A network of powerful ground-based observatories like the Keike Observatory in Hawaii with its massive 10M twin telescopes also joined the effort to track it continuously. This wasn't just about taking pictures. The goal was a deep analysis under the guidance of experts like Dr. Karen Meech, a leading astrobiologist renowned for her work on distant comets. This comprehensive approach was designed to replace speculation with an overwhelming body of evidence. NASA's mission was clear: to determine with the highest possible degree of scientific certainty the true nature of this interstellar visitor and let the data tell the real story. Comet behavior confirmed. So, what does a comet actually do when it gets close to the Sun? The answer to that question was the key to solving the 3E Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3Y Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet reacting to the Sun's energy. Its initial lack of a tail was simply because it was too far from the Sun for its ices to sublimate. The final verdict from the data was it looks like a comet and it acts like a comet. So there was no need for an exotic artificial explanation when a natural one fit the observations perfectly. Music, chemical composition analysis. Here's what really matters. You can learn a lot about something by the light it gives off using a technique called spectroscopy. A team of astrochemists led by a figure like Dr. Stephanie Malum from NASA's Goddard Space Flight Center analyzed the chemical makeup of 3I Atlas. This process is like a cosmic fingerprint analysis where light from the comet's coma is split into a spectrum revealing the distinct signatures of the molecules within it. The analysis confirmed the presence of water ice. But it was the other volatiles that were truly telling. They found a carbon dioxide to water ratio of 0.66, nearly double the average for comets in our solar system. The data from JWST also revealed significant amounts of carbon monoxide and traces of diatomic carbon, the molecule responsible for giving many comets their distinctive green glow. Far from being evidence of artificial design, these unique chemical traits told a story of its origins. The high CO2 content suggested that 3I Atlas formed in a brutally cold region of its home star system, much farther from its parent star than where our own comets were born. It was a pristine sample from a truly alien yet completely natural environment. Trajectory and safety assessment. With all the talk of alien technology and malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations made public through the Center for Near-Earth Object Studies showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane. The flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe $1.50, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. But what about the unusual traits that sparked the controversy in the first place? It's important to remember that in astronomy, unusual does not automatically mean unnatural or artificial. Comets, even the ones from our own solar system, are notoriously unpredictable. To provide context, NASA pointed to historical examples like Comet 17P Holmes. In 2007, that comet suddenly brightened by a factor of nearly 1 million in less than 48 hours, shocking astronomers as it briefly became the largest object in the solar system by volume. This was a completely natural outburst, not an artificial maneuver. Cometary physicists like Dr. Michael Kelly from the University of Maryland explained that these events happen when sunlight penetrates a comet's crust and hits a pocket of supervolatile ice like frozen carbon monoxide, causing it to flash, sublimate, and release enormous amounts of gas and dust. These anomalies are not evidence of intelligent control. They are a normal and expected part of cometary physics. The strange initial behavior of 3 Atlas wasn't a sign of technology. It was a sign that it was a dynamic natural object. Scientific value of interstellar visitors. So if it's not an alien ship, why is 3I Atlas still such a big deal? Because its scientific value is immense. Every interstellar object that passes through our solar system is like a pristine time capsule delivered from another star. These objects carry the unique chemical and physical fingerprints of the planetary nursery where they were born. The high concentration of carbon dioxide in 3Y Atlas tells us it likely formed in an incredibly cold, distant region of its home system. Some studies even suggest it could have originated in the Milky Way's thick disk, a population of older stars, making the comet potentially over 7 billion years old, predating the formation of our own sun and planets. Scientists could test this hypothesis by analyzing its isotopic ratios. For instance, the ratio of carbon-12 to carbon-13 and comparing it to other stellar populations. That makes it more than just a passing rock. It's a preserved fragment from the dawn of another world, providing invaluable data for our models of galactic chemical evolution. Music. Comparing three interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3. Atlas was the third interstellar object detected, and it's fascinating how different all three have been. The first one, Oumuamua, was highly anomalous rocky, appearing to have an extreme 10:1 aspect ratio and showing no visible coma, which is what led Avi Loeb to his original theory. The second 2I Boris, discovered by amateur astronomer Gendi Boros, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3 that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical or if we are an outlier. In the end, Comet 3I Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Future Facts.